Jai Hind everyone, myself Ankita, Faculty of Department of IT, Akgec. Today I am going to discuss Unit 1 of Software Engineering course. So that is taught in third year, BCS 601. So I will be discussing the important topics of this unit. So this is the content I am going to cover, that is software crisis, introduction to software engineering, software components, software development life cycles, models. So these are the topics that I am going to cover. Now, so before beginning the course, I would like to lay emphasis that why are we learning this course. So to begin with, the simple reason could be since we are becoming software engineers, we will be studying the software engineering. So, but the reason is more. So when in 1970s, when the software craze was increasing, so the people was just collecting the requirements, preparing the code, and then they were testing it. But after some time, as the demand increases, the size of the project increases. So there was very difficulty in delivering the software products on time and within budget. And even there were many software failures that they have witnessed. So software crisis refers to the numerous challenges and difficulties faced by software industries during 1960s and 1970s. So these software crisis term was coined then only when many software projects were not being able to deliver on time within budget. So the reasons were there was increasing demand, increasing complexity, and increasing challenges, but we were using the same workforce, same methods, and same tools. So there arises the need of new techniques, new researchers, so as to ensure the completion of software projects on time. So what was happening at that time was the development teams were exceeding the budgets. There was late delivery of the software. There was poor quality software delivered. The software was not at par that we wanted. There were no complete user requirements. Users were not able to give their requirements completely. There were difficulty in maintenance and uneasy to use. So these were various challenges the people were facing at that time, which leads to the research of how we should develop the product, what's the process we should follow to develop the product. So the various software failures, the first software failure that I want to lay emphasis on was the Ariane 5 rocket explosion. So the European space agencies took around 10 years of time to make that rocket, but the rocket destroyed in 39 seconds of its launch. Why? What's the reason? The reason was very small. It was a floating point error that occurred because a 64-bit number was converted to a 16-bit number, 64-bit number was converted to a 16-bit number, and there leads to overflow. So when there was overflow, the system crashed and your rocket exploded. So that was very much loss of money. So therefore, the need arises of software engineering. So what is software engineering? Software plus engineering. The software, what is software? A software consists of programs, that the code that we write. Documentation. Documentation is all the documents that we create while producing that programs is known as documentation. The documentations are all the documents that we create while when we are just preparing the software, right? And what are the operating procedures? These consist of installation manuals or operating manuals. How should we install the software and how should we operate that software? So all these combines forms the software. What is engineering? So engineering is a process of designing and building something that serves a particular purpose and find a cost-effective solution to the problem. Now, the thing is that engineering means that we are here to solve the problem in a step-by-step manner. So now a purpose of software engineering is that we have to solve the problem of how we can make a successful software in a methodological way. So what is software engineering? Software engineering is a discipline whose aim is the production of quality software that is delivered on time, within budget, maintainable, and also satisfies its requirements. So this is a wholesome definition of a software engineering, that we need to prepare the quality software and that software should be delivered on time and within budget. And also, most important, it should satisfy all the user requirements. So what is SDLC? Software Development Life Cycle. It describes the various phases which are involved in the software development process. What steps we should follow to make a software, all these steps forms your SDLC. So it is also a period of time that we start when a software product is conceived and end when the product is no longer being used. So when the concept of that software has come, that's where your SDLC cycle begins. And when the software is being last used, that's where the life cycle of a software ends. So what are the various phases of SDLC? Now, these are the common phases that you will be observing in your SDLC. The first is your requirement gathering and analysis. So this is the first phase in which we collect the requirements from the users. We collect all possible requirements that we can collect, and then we try to analyze those requirements. And after analysis, we try to document those requirements. So we document the requirement in the form of SRS, that is Software Requirement Specification, which act as a contract between the software company or software development team and the customers. So basically, SRS will consist of all the requirements that has been laid down by the customers in a proper formatted manner. Second is design phase. Now, once we have the requirements, we need to convert these requirements in a format that it can be coded, right? So that formatting is your design. Here we identify the modules that are going to be present, and then how these modules are interacting with each other. We are designing all the workflows. So here we are breaking the requirements into multiple modules. So that is your designing phase. Now in designing phase, we make two types of design, that is high level design and low level design. In high level design, we try to formulate the architecture of the software. What are the modules? How the modules are going to interact with each other? That all be designed in your high level documents. Whereas in low level design, we try to understand how a module will function, right? So here we're not concerned with how we are going to implement, but we are just concerned with the designing of the software. Likewise, when you are building a building, okay, so you are constructing a building, so the architect lay the design of the building. So that's happened in your designing phase either here. So we are laying the blueprint of the architecture of the software. Next comes your implementation phase, that we are learning. We are learning various software languages to implement the code. So here we are implementing the code in the implementation phase. Now in testing phase, we are testing the entire code that we have written. So testing also consists of two types, that is functional and non-functional testing. In functional testing, we are testing whether the requirements that was laid in your SRS has been fulfilled by the that is software that we have created or not. That is your functional requirements. Whereas non-functional requirement will consist of all those requirements that are concerned with the quality attributes, whether the software is reliable, whether the software is robustness. So we all check those attributes. So basically we are just testing whether software is following the requirements and how it is doing. So both of these we are testing in your testing phase. Next is your deployment. So once we have tested our code, we are satisfied that whatever was laid down in your requirement phase has been fulfilled. So we go to the deployment phase. We actually deploy the software at the customer site. And then come the last phase, that's maintenance. When we are in this phase, we are trying to do some corrections. So if the customers found some problem in the software, we are correcting it in the maintenance phase. Or if the customer needs to add some few more functionalities, we are adding that in your maintenance phase. So maintenance phase is just after support of your software. So these are the various steps of your SDLC, that is requirement analysis and gathering, designing, then implementation, testing, deployment, and the maintenance phase. So this is the generic step that we follow while making the software. Now we have various models that is being defined, that is waterfall model, the prototype model, spiral, evolutionary, and iterative enhancement models. Now these models have all these steps, but in which order that we need to run these steps, this depends on the model. So let's learn what are they. So before all these models, this simple build and fix that we usually do when we are working in a smaller software. For example, we're just building the code, then we're testing it, then building the steps. That is a whole spiral process. Now the problem is, as the size of the software increases, it becomes difficult to follow this model. Why? Because the code become, unenhanceable. It cannot become unmanageable to manageable. So therefore, only for smaller size projects that we all students do, then we can use build and fix model. Next is your waterfall model. So as you can see, there are all those steps that we have learned so far. That is feasibility, requirement step, designing, testing, and implementation, testing, and the maintenance. So these are the steps. And the first step is a feasibility study, in which we try to find out whether the software that we are undertaking is feasible or not, whether we will be able to construct that software or not. So we check for the feasibility in the feasibility study, and then same other step that we have discussed so far. Now the main characteristics of waterfall model is that it says that, you can see there's a cascade of waterfalls. It's looking like a cascade of waterfalls. It says that we cannot move to the second step until and unless we have completed the first step. So we cannot backtrack. So if I am doing the feasibility study, I have completed the feasibility study, then only I can move to the next step, that is requirement analysis and specification. Correct. So we can only move to design phase if I have completed the requirement analysis and specification step. So we cannot move back. So that is the main characteristic feature of your waterfall model. So waterfall model can be applied to situations when the requirements are well understood. We are able to understand the requirements. That's very clear and fixed. They're not changing. Requirements are not changing. But that is not always the case. The requirements always change. So please remember this case, requirements always change. So, but there might be some scenarios where requirements do not change, right? So in such scenarios, we can use waterfall model. And technologies are understood, ample resources and required expertise are available to support the product. So main is, since we are clear about our requirements, so we can move to the next phase only when this phase is complete. So if in the design phase, my requirements are getting changed, the customer is saying, no, I want to add some more requirements, I want to modify those requirements now. In such cases, your waterfall model won't work, because waterfall model doesn't allow to move back. So because if in design phase you are encountering more changes, you cannot move back to the requirement phase to make the changes. So that change request will be rejected. So in such cases, we cannot use your waterfall model. Next is your prototype model. Now, prototype model says that when the requirements are not clear from the customer side, the customer is not able to understand how to convey the requirements or not able to understand what he wants from the software, we go to the prototype model. So in prototype model, we try to understand as much we understand from the customer, and then we create a prototype of it. Now, the prototype is a partially implemented software. It's just the screens. Okay, so it is not like we are going to use that prototype for the development. It is just for the understanding of requirements. So here we create the prototype with a limited functionality, and we try to show that prototype to the user. Now, if the user got satisfied with the prototype, we can move ahead to code it. Otherwise, we will again make the changes. So you can see in the requirement gathering, we have gathered as much requirement as we can, and then we perform a quick design, we build a prototype, and then we get that prototype evaluated by the customer. Now the customer will refine those requirements and it will suggest some changes, right? So we will again quickly design, again build the prototype, and again we will evaluate that prototype from the customer. Now, if the customer is satisfied, we can move to the next phase, that is design, implement, test, and maintain, right? So this was your prototype model. Next is your iterative enhancement model. Now, sometimes it happens that the software project size is so much huge that it needs years of development. In such cases, what we do, we divide or prioritize the requirements, and we say, okay, these requirements we want it now. Okay, so what we do, we iteratively enhance the versions. So it's implementation of a small set of software requirements and iteratively enhances the evolving versions. So in iterative enhancement, development begins by specifying and implementing just part of the software. So we can just see the example, like in the first phase, we are performing all those steps of designing, testing and implementation, and we are giving a release. For the next set of requirements, we again following the steps, and again we are doing a release. So the software is, delivered in an iterative manner. So we have various releases. For as an example, I can tell you that suppose we have in university, and the university is automating its processes. Now suppose that there are many modules in university, that is admission module, attendance modules, employee management, marks, right? Marks module. So all these modules cannot be implemented in a very small time. So if we have only let's suppose 2 months. So, and the admission is going to start in 2 months. So what the university will expect? It will expect that, okay, just give me the admission module at to 2 months, and then iteratively you can just keep on adding. So first admission, then you can add on the attendance, then you can add on employee, and then you can add on that is marks. So these are iteratively we are enhancing the software and we are releasing it. So that is your iterative enhancement model. Next is your evolutionary development model. Now it says that when the software or the requirements are such difficult to use, difficult to understand, so we follow this evolutionary development model, in which we provide a scope of feedback and improvement at every stage of the system development. It means that suppose we have just beginning with the requirement phase. Now requirement phase, we want the feedback from the user. So we can just inculcate that feedback part in the requirement phase. So here what we are doing that, we are just, prioritizing the requirements on the base of the understanding. And after that, at each phase, we are giving some product. Not that, please keep in mind that the product is not usable. It is just a part of the requirement. So here we are implementing the requirements by category then priority. So we are just categorizing the requirements, and those requirements which are clear, we are implementing that. And then after some time, if the more requirements are getting cleared, category wise, we are implementing them. So evolutionary model, it says that we are initial version, this might not be working. Okay, this might not be working. And then again, we are doing the development phase for the next set of requirements, intermediate version and the final version. So that was your evolutionary development model. So in iterative enhancement model, we are getting a usable product in every release. Whereas in evolutionary development model, we are just building the products in some versions, but each version might not work. So in the main difference between your iterative enhancement model is that, and evolutionary is that, in iterative enhancement is mostly followed in those cases where the size of the project is huge and we want the product to be released in versions. Whereas when the requirements are not much clear and we want to, make the product in the various parts, we can do it by evolutionary development model. Next and the last one is your spiral model. Now, all this model that we have discussed so far hasn't have concept of risk. So risk is always there. The spiral model is providing support of risk handling. So in the diagrammatic representation, it looks the spiral with many loops. So there are many loops. Each loop will represent a phase, right? This loop will represent a phase, and the number of loops will depend upon the software. So as and when the case, each loop of the software represents a phase, and the number of loops is dependent on the project to project. Now, you can say we have a cumulative cost is dependent on this dimension, whereas the radial dimension will depend upon the progress of the course. So this will tell you how our development is progressing, and this will depict the cumulative cost. Now you can see this is one phase, okay, this phase, and this is another phase. So every phase is divided into 4 quadrants. You can say in first quadrant, for example, the first phase is representing your requirements. Okay. Now, first phase is representing the requirements. Now, in first phase, this first quadrant will tell you that we have to determine the objectives, alternatives, and constraint. Now in next quadrant, I will do the risk analysis and then I will create an operational prototype. So after analyzing the risk, I will create one prototype based on my understanding for the requirement phase, and then I will develop the product and verify for the next level. So then I will check for the next phase, and in this fourth quadrant, I will plan for the next phase. So in this one loop, we are having the requirement phase in which we are determining the objectives, evaluating the alternatives and identifying as well as resolving the risk. Then we are creating the prototype and then we are planning for the next phase. Similarly, for the next design phase, now our design phase is depicted by this spiral, this one. In design also, we are doing the same thing. We are determining the objectives, identifying the risk and resolving them, making the prototype, and we are planning for the next phases. So in this way, our spiral works and we are evaluating risk at every phase of the SDLC life cycle. So this is how we do in spiral model. Spiral model is used in cases where we have high amount of risk involved, but the disadvantage is that it is very costly and it's difficult for us to understand. So in this video lecture, we have discussed about the various SDLC models, the need of software engineering and software crisis. Thank you.